Hi everyone, welcome to Java Techie. In this tutorial, I will guide on deploying Spring Boot application to AWS Lambda. If you are looking for an affordable way to host your Spring Boot project, then you are in the right place. This tutorial covers everything you need to know, including the benefit of serverless computing and a step-by-step deployment guide. Okay? Alright. Before we jump into the deployment process to AWS Lambda, let's take a moment to discuss why we might want to choose this approach. So if you think traditionally we do deploy our Spring Boot application packaged as a jar or WAR file, or if it is a containerized application using Docker, we deploy it to the Kubernetes. For example, let's say I have this Spring Boot app, then I need to generate the jar or WAR file, then I need to deploy it to any server. It could be your Tomcat or it could be Elastic Beanstalk. Okay. Similarly, if my Spring Boot application, if I am using containerized platform, then I need to create the Docker image. Then I need to deploy it to the container platform like Kubernetes, or if it is a AWS, I can go for EKS. So this approach works well. Then what is the problem here? Simple, right? So let's consider an use case. You have deployed your application to a single server. Forget about this container platform. We'll discuss that in other tutorial. Now consider your application is deployed to the single server which can handle 10 million requests per second. But in future your application is getting more requests, let's say 100 million per request. Okay, then this particular server will not able to handle those many requests in a single go. So for that, what you need to do, you need to take the headache of scale up and scale down based on the number of requests coming to your app. Correct? Now that's a challenging task for us, isn't it? It comes with the responsibility of managing and maintaining your own server, including patching, security and scaling. So being a developer, you need to take care of managing your server, which is really a tedious job, isn't it? So how to overcome this? So that is where this AWS Lambda came into the picture. Okay. AWS Lambda, on the other hand, is a serverless compute service that allow you to run the code without the need to provision or manage the server. So you just generate jar or WAR file, give it to AWS Lambda. Lambda will take care of managing the server and scaling it up and down based on the need. So with AWS Lambda, you only pay for the time you have consumed it, which makes it an ideal solution for project with variable traffic that can scale to zero. By deploying your Spring Boot app to the AWS Lambda, you can offload the burden of server management and focus on developing and delivering your app. That's quite innovative, isn't it? Now that we understand why AWS Lambda is great for hosting our application, now let's quickly demonstrate this AWS Lambda by considering a CRUD API example. So what we are going to perform, we are going to create a Spring Boot app, let's say Spring, then we'll deploy it to the AWS Lambda. Then we can try accessing this application which is hosted to the AWS Lambda, which is serverless. But rather than doing that, we'll also add one API gateway so that user can send request to this API gateway, and from API gateway request will route to the corresponding Lambda function, okay, which is nothing our CRUD app. Fine, this is what the simple scenario we are going to develop. So without any further delay, let's jump into the code. Let's get started. So first, let's create a Spring Boot project from the scratch. I can create the project from the IntelliJ IDEA from this particular page, but let's not do that. Rather, let's create a Spring Boot project by using the Maven archetype designed for AWS Lambda deployment. Okay, so if you'll go to your IntelliJ IDEA and if you'll click on File, New Project, give the project name AWS. Now choose the correct JDK version you want to use. Now in catalog, you need to choose the Maven Central. Then if you see here, there is a section called archetype, and here you can find the drop down. Just type Spring Boot 3. Okay, or just type Spring Boot. If you see here, this archetype for Spring Boot 3, this is for Spring Boot 2, and this is for lower version. Since we are using Spring Boot 3, we will choose this particular archetype to create a Lambda specific project, and then we'll validate what all things was inbuilt by this Maven archetype. Okay, just click on OK. If you see here, it will take few seconds to download the dependency. Now if you go to the pom.xml, which was generated by this Maven archetype, you can find something AWS Serverless Java Container Spring Boot 3, which enable running Spring Boot app on AWS Lambda. And apart from that, if you will scroll down in the build plugin section, you'll find something called assembly-zip, which will generate the zip file of your app rather than generating a jar file. It will generate a compressed zip file which you can upload to the AWS Lambda. We'll learn that in a moment, but this is what the few inbuilt thing will be added by this Maven archetype when you are creating a Lambda project. Fine. Now also if you will verify the project structure, you can go to the src main Java, and if you can see, there is a class called stream lambda handler which was auto generated. If you will open this class, you can find something stream lambda handler implement request stream handler. Okay, so basically what this particular class will do, it will act as an entry point for AWS Lambda to route request to a Spring Boot app using the AWS Lambda proxy integration. All the requests will landed to this particular handler. Now handler will forward that request to your Lambda function or the Spring Boot app what you have designed. Okay. Apart from that, if you also observe, there is something called template.yml. This is the file also auto generated. So if you read the content of this file, what it says, okay, this is of AWS serverless function, and this is the handler who will receive all the requests, what Java version. I mean, there are few information, right? This template simplifies the deployment process by automating the setup necessary AWS resources and configuration which required to host a Spring Boot app to serverless API on AWS Lambda. Okay, so this simplifies your task to make the things ready for your deployment. I hope you see how the Maven archetype for AWS Lambda and Spring Boot streamline our work. If so, let's go ahead and start writing our CRUD API. So first what I will do, I will create couple of packages. So by default it also created one controller class with some static message. You can test it, but since we are going to perform the CRUD API, let me create another controller class here. Let's say we'll deal with the course. Okay, so I will define course controller. Okay, so let's start create our DTO first. Go to the DTO, create a new class called course. Then let's define couple of field, ID, name and price. So let's add the Lombok specific annotation to avoid the getter and setter writing it manually. So it seems we don't have the Lombok dependency. Let's add the dependency first. Go to the pom.xml, then just scroll down and add the dependency. So I will add it here. Anywhere it's fine, right? It's just a dependency, so just add it here. Just update your project. Now just define the annotation. I need all argument constructor. I also need no argument constructor. I'm not going to use the database. Rather, I will create a list and will perform the CRUD operation on that list. So that is the reason I have not defined any entity. It's just my DTO class. Okay. So you can give a try by adding a database instance from the cloud or from your local. You can give a try. But for now, let's go with the list. Now let's start create the service class. Course service. Annotate this @service. Then let me add the CRUD operation specific code. Since we are playing with the list, there is not complex logic. Just add it here. Just import the course. Okay, all good. So there is no rocket science in this code. We are just adding the course object to the list. Retrieve all from the list. Retrieve a course by ID by just doing the filter. Then update the course, just update the index in the list, then delete the element from the list. Okay, that is what the simple logic we have. Now similarly, let's create a controller class. It's already there. Let's annotate this @REST controller @request mapping. Define the root URL /courses. Okay, now just inject the service class and define the endpoint. So let me simplify this by adding the code. We just need to import all the required classes. All good, right? So again, this is the simple endpoint. We have the post mapping, get mapping, put and delete to perform the CRUD operation. Okay, from controller we are just calling each and every method from the service. That's the simple logic we have. Correct? So all good. Since we are done with our project, now next let's package it so that we can deploy that package to our AWS Lambda. Okay, that is what we understand, right? So we just need to create the jar or zip file which we can directly upload in AWS Lambda. So you know how to generate the jar file, right? Or you know how to package your app. So just go to the Maven, then go to the lifecycle, just install it. If you don't want to do in this way, you can also run mbn clean install or mbn clean package. Okay, it is up to you. So I'm using this approach to build the app. So build is succeeded. Now if you will expand your target folder, let me zoom this for you. So if you expand this target, you can find it created a package.zip. Okay, so this particular zip file contains all your packaged class which is required to run in AWS Lambda. With this file ready, we can proceed to deploy it to the AWS Lambda. So to do that, to deploy your app to the AWS Lambda, you need to go to your AWS website. Okay, you need to go to your AWS console. Then first step, you need to create a function. Okay, make sure to choose the correct region. I have chosen here Asia Pacific Mumbai. So AP-South-1. Now here I need to create a function. Just click on it, then just add all the required field. First choose it author from scratch, then give the function name. So I'll give course-service. Then choose the runtime. For us the runtime is Java 21, right? So we have used JDK 21, so runtime is correct. Now nothing to do, just click on create function. Once your function created, you will see this page. Now if you will scroll down in the code section, you will find a option to upload from. Just click on this, upload a .zip or jar file. Click on it, click on upload. then you need to give your jar file, okay, so which we just generate. So we have created this project, right? Just open it, go to the target and give this zip file. If you observe, the size of this particular zip is 17.1 MB. Okay, just click on it, click on open, then click on save. So you will see these messages once your zip file is uploaded successfully. Now what you need to do, you need to come to the configuration, not here. If you'll scroll here, you need to edit your runtime setting. Okay, so you need to set the handler, right? So if you remember, it created a by default handler for us, which is stream handler. This is what the handler it created for us. Okay, we need to provide this handler information in the runtime setting so that all the requests will come here, then it will delegate to your application. Okay, cool. So the package is org.com.example. Copy the class name. You need to provide fully qualified path of it. Just go here. This is the class name. Also I need to copy the package org.example. org.example stream lambda handler and call the handle request method. Okay, all good. Click on save. So the function is updated successfully. Now all good. Now since our application hosted successfully to AWS Lambda, what we can do, we can test the API. Okay, so just click on this test, then just give the event name which you want to test. Let's say course API. Now just choose this API gateway AWS proxy. Now here just provide the path of your endpoint. For us, the endpoint, let me minimize this. If you'll go to the controller class, the endpoint is /courses, right? So let's try accessing this get mapping to get all the course and we'll see the result. Okay, just go here, change the URL and HTTP method of type get. All good. Now just test, hit on the test button. Can you see here? The word is empty because it is not a DV, right? We have used the hard-coded list object here. So if we'll fetch anything from the list, currently we have not added anything to this list. That is the reason we are getting empty response. So let's add something to the list, then we'll validate that. Okay, so rather than play with this particular Lambda function, let's integrate to the API gateway so that we can happily access all our endpoint. Okay, so you can see here currently the result is good. Our Spring Boot app is up and running in AWS Lambda. You can see the Spring Boot banner, right? Okay, so this is not the way to access your Lambda. This is just for the testing purpose, but to access it, let's quickly integrate the API gateway. So to create this gateway, just I'll duplicate it, then go to the service again, search here in the service gateway. You can find this, right? Click on this API gateway. So this API gateway will act as a proxy forwarding incoming request to our Lambda function. Okay, so this is the home page of API gateway. Scroll down. So yeah, you need to click on this REST API, click on build, give the API name. I will give something like course service or course REST API, anything you can give. Select new API, then give your name. Don't touch anything, just click on create API. Fine, you will find this page. Now here let's click on create resource, give the path here. Okay, so what I'll do, just define here proxy plus. Okay, in this way any request coming to API gateway will redirect to my Lambda. Okay, that is what if you see here in the template.yml file, See here. This is the path from API gateway. Fine. Just go here, create the resource. Next, just click on create method of type any, because I will trigger the request from gateway to the Lambda function. So I can define the method type as any rather than defining individual HTTP method. And here I'll choose the Lambda proxy. If you observe here, I got the option, it was getting my Lambda function here, right? Choose that. Then all good. Click on create method. Now you can see this dashboard, right? So from here you need to deploy your API. Just click on deploy API, new stage, give any stage name. So let's consider it as a dev or prod, UAT, whatever you can define. Okay. Now click on deploy. Now if you will expand this, you can find different type of HTTP method, but let's try to access our course endpoint from the root URL. This is what the root URL, okay, which we deployed. So just copy this, go to the postman, new HTTP request, paste the URL. First let's add couple of course object, then we'll try to fetch them. So let me build the course object, give some name, then price, give something. Okay, now let's send the request. We are getting this error region, we have not specified our endpoint URL. Okay, so go to the controller class, copy this, then slash, paste it. Now send the request. You can see the result here, right? Course is added to the list, or you can consider added to the system. Now let me add another course to, let's say, Hibernate. We have added 2 record. Let me add one more record. So the post API is working correctly. We are able to perform or add the record to our system. Now to fetch that all the course, available course, you can change it to the get, remove the body, send the request. You can see all the 3 record here. The get endpoint is also working. Now if you want to filter a single course object, just add it, send the request, we can see the result, right? So this is what endpoint we are exposing. Now if you want to check the put mapping, what is the input we are giving? Course object and the ID which you want to update. Just go here. Let's say I want to update price of this course, which will be of type put. ID is correct 101. So let's say I want to update price. Fine. Now if I'll send the request, it is updated. Now to validate that, I can copy this, go to the browser. You can test from here, but you will find the better visibility in the browser. See here, the record got updated. Correct. Now the last one, let's try to access the delete API. So we'll delete this particular record. Okay. So go to the postman, ID is 103. I want to perform delete, remove this, send the request, no content. Now if you'll refresh it, you will get only 2 record. Okay, all the CRUD API create, update, retrieve and delete successfully we are able to access from the API gateway. We send request to the API gateway. API forward that request to the Lambda function. Now Lambda function forward that request to the stream handler class, and stream handler connect to our endpoints. Okay, we are successfully deployed our application to AWS Lambda, which was designed using Spring Boot 3, and we are able to access it by integrating to API gateway, right? Yeah, so that's it. If you have any doubts specific to this Lambda function, or integration of API gateway or anything or any concern, feel free to raise your hand in a comment section. I will definitely look into the comment and I will try to respond them. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.